The Richter scale is used to calculate the intensity of an earthquake based on the amount of observed motion. An earthquake's Richter scale measurement is called, or rather is calculated using this formula, where A is amplitude of the observed motion in micrometers. What is the amplitude of an earthquake that measures 8.15 on the Richter scale? So this 8.15 is our R value. So here, if we kind of use the idea that most things can be solved if we write out the first quadrant for real world, knowing that we don't deal with negative time, we don't deal with negative Richter scale stuff, things like that. We can solve a lot of these. So what we do is we draw the first quadrant, we label our X and Y axis. I need to ask myself, what refers to X in this problem? That's the A. A is in the place of X. So A is amplitude. I'll put that here. Amplitude. And R stands for the Richter scale. And R is in the place of Y. Okay, so here's our values here. Now let's see what they gave us. They gave us an 8.15 on the Richter scale. That means that R is 8.15, or you could say that Y equals 8.15. So I'm going to look for where this intersects this equation here. So I'll go to my graph here. Solve it first by graphing. We type this in. We know that on this graph we have the equation first given to us as 3.75 plus log, and it doesn't yet say a base, so we assume the base is 10 of x. We graph that, and then we also now have this y value, menu actions text, and we can say that y equals 8.15. Now, when I drag it over, it will not graph right now on the axis because this value is not high enough. 8.15 is off the screen, so I need to go higher. I'm just going to put 10. And as I look here now, as I graph it, I'm still a long ways from being able to see this cross. So I'm going to extend this way out. I'm going to say like, I don't know, 100, because I'm not even close. And I can see I'm still not even close, so we can change that now to, let's try 1,000. Still not there, so I change it again. Let's go to 2,000. Oh man, I'm not even close at all. I can go to 10,000. It's 10, followed by 3 more zeros. And I look, and I'm still not there. Oh my goodness, do we need to go to 1,000,000? 1, 2, 3. 3 zeros and 3 more zeros. Finally, I got a cross. So we got a cross over here. So we now go menu, analyze graph, intersection, and I'm going to see where this crosses. And this doesn't help me much because it says 2.51 e to the fourth. That means that decimal needs to move right 4 times. So it kind of throws this off. It's not very, so we're saying the value should have been 2.51. So I'll go 2.6, and remember it's 2.5, and then this decimal moved 4 times. So I'll do 2.60, and the decimal need to move 2 more times. That was twice, and now 2 more. If I do this, now I have my values this way, and I'm going to change this to -10. It doesn't need to be that far backwards. And so now we can get a little bit more of a better picture of how they would cross. And this point was, let's say it again, menu, analyze graph, intersection. Unfortunately, it's just going to show it to us that way. So another way we can get it more exact is you can insolve, or using algebra, what we do is we put in 8.15 over here equals 3.75 plus log A. So to solve this, I would subtract that 3.75. And as a reminder, we should get 251 followed by 2 zeros. That's what we're looking for. Something along the lines of this number. I guess that'd be 25,100 in micrometers. That's what we're looking for here. Something around that number. And so I would subtract that. And when I subtract, I would have 4, I believe that's right, equals log A. And now, how do you get rid of the logarithm? You would say the base to this power, so 10 to the 4.40 will equal A. So this would be the exact answer. A should equal, I'll come over here, Control T, oh, I'm sorry, Control Control Doc will add a page. Go to calculator. 10 to the 4.4. This is our exact answer, 25,118.86. That's our exact answer there. Shrink this down. And so now that I've come to the very end, why don't I show you the easiest way of getting this, which some people are going to be at this moment asking themselves, why didn't you show me this from the start, the easiest way? Well, I wanted to show you the algebra as well as the graphing. So now the easiest way that our calculators make possible is we could have insolved this. Anytime you have an equation with an equal sign, you can, in only one variable, you can solve using insolve. So I'll come back over here and show you can type in insolve, or you could press menu 3-1. You type the equation as was given to us, 8.15 equals 3.75 plus the log of, it said A, and then you would do comma, the letter you're looking for, which is A. Press enter. You see that these answers are exactly the same. And it's because insolve will always solve your equations as well.